Hello. Today I'm going to start a new topic which is network application security. In my previous lectures, I have discussed about uh, various cryptographic fundamentals, protocols and schemes that are used to provide confidentiality, authentication and integrity. So in this set of lectures about network application security, I'm going to discuss how those cryptographic protocols and schemes, those fundamental things, are really used for our day-to-day data communication, mainly internet communication. So this is the outline of the things I'm going to discuss. Basically, I'm going to discuss about basic network concepts, which is kind of a recall about your network course, and web authentication, application protocols over security protocols. In there, we will discuss about SSH or the Secure Shell Protocol and SSL TLS protocol suite, and little bit about further reading guidance and technologies that we can use in practice. So I'm going to start off with basic network concepts. I mentioned that this is kind of a recall for your network course, network or web application course. So what is a computer network? My kids are shouting there, so there may be a little bit of disturbances. Anyway, so network is we can consider network as a connection of devices that send and receive data. So the devices that send and receive data can be personal computers, laptops, mobile phones, tablet, or routers, or any other card readers, anything. Those are the devices. They are connected together. We can consider that sort of a setting as a network. So this connection, the connection of these devices, how these devices are connected, that can be the a physical connection or a wireless connection. Physical connection can be like anything, like any tangible kind of connection using network cables or fiber optics or whatever tangible physical things, connections. And for wireless, it can be radio signals, infrared, satellite, or any kind of wave that can transmit data. So it is very important that we identify the type of connection, the physical or the wireless. Based on that, we can think about how to make our, our setup secure. So when we have a setup, kind of devices connected together using a channel, maybe physical or wireless, in that setup, to provide security, that means we have to secure both of the things. That means the devices as well as the channels or the medium of data transmission, communication channel. And when we have the channels, that means I mentioned they can be physical or wireless. So if we have set up like every device is connected through physical channel, wired connection, and it is inside a building like a local area network, this kind of setup, for this kind of setup, it is easy to provide the setup secure, because we know that devices are connected through physical channels. Nobody else from the outside can access to these channels because it is isolated. It is a local area network, and if somebody is trying to connect to this setup, that means they have to at least use a computer or tap a wire and connect their device through that tap. So that's a physical channel. Providing a security for physical channel can be kind of easier because it's physically a tangible thing. Without touching it, nobody can steal data from it. But if it is wireless connection, that is harder. Even though, like, let's say, like, we have a similar setup, we have a set of devices inside a building, but we use wireless channel to do the communication or the connect the devices. But somebody from the outside, even though they cannot come into the building, there's a like very likely that they can receive the wireless signals to the outside, so they can connect their devices to that medium, the channel, or the that wave. So that kind of setup, it is very difficult to monitor and manage how they get data or how they inject data to our setup. So that's a difficult task. And when we have like, that's what we have to understand, that when we have a setup, we have to really consider that we have to understand that we are going to secure both the devices and the channel protected, and based on the channel we have to consider, like, or we have to take necessary actions to make our setup secure. Like, if it is wired connection, it is easy. If it is wireless connection, we have to pay more attention to get the required protection. And when we have this network system, we know that devices are connected to the network, and also there is a software to handle or the manage how the data is transmitted and how data is uh, processed during for that transmission. So often we use several layers. In the several layers, different kind of processing is done to the data. As a receiver or as a sender, these kind of processing should be there. And also, to provide the required processing, there are a set of protocols in each layer. So this layer is kind of a software kind of thing to do processing for data transmission. Each computer connected to the network has these layers, computer or whatever device. And for a message to be sent from a device, it must pass down all the layers on the sending computer. And when a message is received, it must go up all these layers on the receiving device. So that's how these layers are arranged. So at each layer, there is a protocol which defines message format and several things. So protocol is a set of rules. In this context, we can say that set of rules govern the exchange of data between devices. But generally, a protocol is a set of rules to do something. So now we know that network is a connection of devices that uses data in our context, that devices that use data, and those devices send and receive data. For that, we have to connect the devices using a channel, a medium. So that channel can be physical or wireless, and in each device there are a set of layers that do some kind of data processing which is required for data transmission through the channel. So for that data processing, at each layer there is a protocol. So usually a protocol is a set of rules. That means it is a kind of a program that do certain tasks. So according to the Internet Engineering Task Force, IETF, this is the Internet Protocol suite. So there are 4 layers, and each layer I can show you the examples for each layer. So let's first look at the layers. There are application layer, transport layer, internet layer, and link layer. I'm pretty sure that you have covered these things in your networking and web application courses. And you know that in application layer, applications, what are the applications? Applications are the uh, softwares we use in our computer. So it can be web application like using a website, anything uh, doing through the web browser, a web application that uses HTTP or HTTPS protocol, the hypertext transfer protocol. An email application or login application, likewise, they are the applications in a computer. So we identify that there are several layers, and in each layer we have different set of tasks. So in application layer we have applications, and from the application layer data is transmitted the next layer to the next layer, which is transport layer. So it can be connection oriented TCP or connectionless UDP, and from that layer data is transferred to the internet layer. This internet layer, so the transport layer is responsible for creating packets for transmission. And when data is transferred to the internet layer is responsible for providing the addresses for the devices. So if I have a device, that device has an address. Through that address, any device from in the network can locate my device. It's like address of my house. Using the address, anybody can send a letter to me. So addressing that can be IPv4 or IPv6, and after that data is sent to the link layer. Link layer is actually the linking between the device to the outside network, to the network. So packet framing, physical connection, WLAN, that can be web, or WPA, that is wireless routers, and or ADSL connections, everything connected, everything regarding that connecting the device to the physical channel is happening in this link layer. The internet layer, addressing is done, and transport layer, the creating or the processing the packet is done, and in the application layer, data is working with the applications. So this is a breakdown of how these layers are arranged. And once data is sent from an application or from a computer, so usually in a computer some application is running, that means data is required for that application. So application from that means first the application layer is activated. From that, data is sent to the transport layer, the processing the packet is done there and sent to the internet layer, the addressing is done there, and then data is sent to the link layer, and through the link layer it transferred to the physical or wireless channel and sent to the other end. So in the other end, data is received through the channel, and first it receives to the link layer. So according to the protocols in the link layer, it does that processing, and then it goes to the internet layer, and in the internet layer it identifies this data came from which computer according to the address of the computer, the sending computer, and then sent to the transport layer and do the pre-processing, like rearrange the the, the packets and send the data part to the required application. And in the application, if it is let's say uh, that application has to send back some data, that data is computed or generated and again sent through these different layers to the other end. So this is how the thing is happening. So these slides will give you the brief about different layers. You can read it. And here uh, when we talk about a client server setup in internet, so each application server listen to for a message on a particular port number. So we know that application layer that is like that is responsible for providing data to particular applications. So how these applications are identified in a computer or a device, that is using a port number. For example, I can say uh, if a letter comes to a city, then let's say like there are several houses in the city. Each house has a number. And once the letter comes to the city, to the post office, from the post office, they locate the house using the number of that house number. So that's similar to a concept of this port. So port is to which application or to which program that this piece of data should be sent. So that information, that setup is handled by using a port number, and which is done in the application layer. So application layer is responsible for assigning a port for particular application, and once the data is received using that port number, it identifies this piece of data should go to this program. So that is how application layer works. And then the other layers work on the processing, the addressing, that means like giving the address of the city likewise. And here there are different port numbers for different applications. For web servers, port 8 or 443. For logging application, port 22 or 23. For file transfer, different port. For emails, different port likewise. And clients identify the machine they want to connect to the using the IP address. So that IP address thing is happening in giving the IP address is happening in this internet layer. So in the application layer, ports are identified once the data is in a computer using a port number, which application should get this data is determined by the port number. So that is happening in the application layer. And in the transport layer, some kind of processing of data to packets is happened, and in the internet layer, addressing is done. So clients identify the machines they want to connect to using an IP address, and clients identify the program they want to use using a port number. Once the data is in the computer, port number determines the application which requires this piece of data. In this slide, you can see a picture about what I discussed so far. So this first part is requesting a web page in a client server setup. In a client server setup, so that means a web application. When you are, for example, when you are trying to access your Facebook, that sort of scenario is addressed here. So you have the Facebook application loaded in your web browser, and you are trying to look at a picture. You just click on that, and once that happens, that request should go from your computer to your web browser to the Facebook server, and Facebook server will respond to that request by sending you the picture that you clicked on. So in the application layer, or that means in the web browser, it constructs the request in a specific format and includes the address information of the server and port number. And in the transport layer, that breaks the request into packets. And when it comes to the internet layer, that means in internet layer it routes or the send this packet to the required destination using the IP address of the server. And in the link layer, packets are transmitted across the wire or the wireless or the satellite, depending on how it is connected, and finally it goes to the server. So what the server does is, server do all these information goes through these layers in the server side, and once the server send the information, it will receive to your computer, your client computer, the computer that generates a request. So receiving thing happens like this: receive packet across the uh, wire or the channel, that happens in the link layer, and from the link layer transfer to the internet layer, that means collect the packet for this IP address. So now your computer knows that the response came from that particular computer based on the IP address. Computer means the server, and then it transports to the transport layer, and there assembles a packet of the request, and that processing thing of the packet is done, and then send the data to the application layer. So in the application layer, what it does is, based on the port number, it sends the data for the application which requests the data. That means the web browser, not to the email client or not to the shell. It sends to the web browser because of the port number it requests. So this is how the data is transmitted in our internet applications, web applications. Uh, I I just explained this as a briefing of your another course. So our real security part will begin on top of this. So from my next lecture, I will explain those things. So for the time being, so I'll again summarize what I discussed. So what's a computer network? Computer network is a connection of devices through a channel. Channel can be physical or wireless. And when we try to provide security, we have to uh, consider that we have to consider that we are trying we should protect the devices as well as the channel, not one thing. So when we have the communication channel, if it is a local area network, and if it is a wired channel, wired medium, that is somewhat easy to give the protection. But if it is wireless, we have to take several precautions, several additional measures to put the security, enforce the security. And this is how the communication happens in our basic, like networked setup. We have layers, and in layers we have protocols, and in different layers different tasks are done, and this is some information about those tasks. And this is about how the programs and devices are identified in this setup using IP address identifies the device, using port number identify the applications. And this is how uh, data is transmitted in a basic client server application, how the web request is done, and once the response came, how the that response again transferred into the client computer. Okay. In our next lecture, we'll discuss about application protocols over security protocols. That means we'll discuss about SSH and TLS protocol soon. Okay. Uh, let's meet in our next lecture. Thank you.